Now we are going to start with the MCQs of thermal properties and temperature. So you can read the question number 1 here. A substance loses the thermal energy, that is nothing but heat, to the surroundings at the steady rate. The graph shows how the temperature of the substance changes with time. You can see this graph is there. This y-axis is nothing but the temperature, x-axis is the time. As the time is increasing, the temperature, you can see, it is decreasing. What could the portion PQ of the graph represent? You can see this portion is there. And the options are given, you can see. So for reference, I have given here a diagram we had seen while learning the chapter, the heating and cooling curves. And this one is particularly the cooling curve. Here the x-axis is the time, y-axis is nothing but the temperature. So while the substance is cooling like this, and if we have two flat lines, this is the first horizontal line, this one is the second horizontal line. So that means there is a state change two times. Okay. So here also you can see there is a one flat line, there is another flat line. That means here it must be a gas, and here it must be a liquid. So gas is converting into the liquid. That's why there are two flat lines or horizontal lines. So this is a gas and it is converting into the liquid at this stage. And we know while the state change, the temperature remains constant. Then after state changes, then again the temperature can decrease, and here again flat curve. Here the you can see this is nothing but the liquid converting into the solid, and while the state change, temperature remains the same. And this curve, you can say this is purely a solid. So we know when the state changes, the temperature remains constant. So this first horizontal line, this is the second horizontal line when the state change occurs. And once the state is completely changed, the substance can heat or cool. So this is purely the gas, this is purely the solid, this can be purely the uh, solid. This is a liquid, this can purely the solid. Okay. So in this curve also you can compare the things. This we can consider the gas. This is the gas converting into liquid. This is the liquid, and this is the liquid converting into the solid. This way you can consider. So you can see the options here. Option number A is gas condensing, which is not possible because while the state is changed, the condensing, this what does it indicate? There is a state change. So in the state change, temperature remains constant, and PQ, the temperature is decreasing, so it cannot be the answer. Then option number B, gas cooling, which can't be the answer again because this can be this first decreasing line. C, liquid cooling, this can be answer here. Here we can see this PQ can be the liquid, and it is only one state is there, and decreasing temperature can be occurred with the single phase or single state. So option number C can be the answer. And liquid solidifying, which can be this curve. Okay, where the liquid is converting into the solid. So while the state changes, this one is liquid converting into the gas converting into liquid, and here the liquid converting into the solid, the temperature is constant. Okay, and here gas is cooling, here the liquid is cooling. So option number is nothing but C. Now the second problem. A student wishes to check the upper and the lower fixed points on the Celsius scale thermometer. You can see this is a thermometer. She has four beakers P, Q, R, S, and here you can see the beaker 1 contains a mixture of ice and salt. Beaker B contains a mixture of ice and water. Beaker R contains boiling salt and salt solution, and beaker S contains boiling water. Which two beakers should she use to check the fixed points? So what are the fixed points? These are uh, the marking on the thermometer, lower and upper marking on the thermometer, so that we can check the temperature precisely. So which four beakers she can use? So we want the fixed point, fixed marking on the fixed lower and the upper point, fixed upper and the lower point on the thermometer scale. So you can see here option numbers PQR, these are the given, and which beaker she can use, so that corresponding options are given. Here the main important thing is that the temperature of that particular substance should be fixed. Then only we can have the fixed points. Beaker P is containing the mixture of ice and salt. Here, if you mix the salt to the ice, what happens? The temperature of that ice basically it decreases. Okay, so we can't have the particular fixed point over there. We know the fixed on the ice, the temperature of the ice ideally it is at 0 degrees Celsius, and the temperature of the boiling water is nothing but the 100 degrees Celsius. Those can be our fixed point, but if you mix the salt to the ice, the temperature can even go below this minus 10 degrees Celsius. So that cannot be the answer. Beaker B contains the mixture of the ice and water. Here we can have the mixture of ice and water where the temperature of both we can have the 0 degrees Celsius. So Beaker B, that is Beaker Q, we can consider. Okay, Beaker Q we can consider. Uh, Beaker R contains the boiling salt solution. Here again, it is a salt is added to the water. Here, if you add this salt to the water, temperature can fluctuate. It can go beyond the 100 degrees Celsius. That's why we can't use this Beaker R. Beaker S is containing only the boiling point. So here we can have the fixed temperature of 100 degrees Celsius. So we can use the Beaker S. So which option is containing Beaker Q and S? We can see this is PR, this is PS, this is QR, and this one is a QS. So we can consider this Beaker for our option, or sorry, for our answer. Okay, so we'll see now problem number 3. Now you can read the question number 3. The same quantity of thermal energy is supplied to two solid objects x and y. The temperature increase of the object x is greater than the temperature increase of object y. Which statement explains this result? So you can see here four options are given, and we have basically how many objects are there. We have two solid objects and the same thermal energy, that means same heat we are going to provide to both the objects, and object X is having greater increase in the temperature than object Y. So what can be true? Okay, because the same heat we are going to provide. Option number X has a lower melting point than Y, X has a lower density than Y, X has a lower thermal capacity than Y, and X is a better thermal conductor than Y. So we will recall here our two formulas of the heat gain or heat loss. The first formula, this is nothing but the heat gain or loss, is nothing but mc del T, where C is nothing but the specific heat capacity, and this is the formula where capital C is used, which is nothing but the thermal capacity, or we can also say it as the heat capacity. Okay, this you can consider the heat provided to the object. Okay, if there are two solid objects and this heat is provided to the object, this is nothing but C multiplied by delta T. Okay. So we consider the same heat is provided to both the objects, and delta T, that is nothing but, this is nothing but the change in the temperature. For object X, that change in temperature is higher, and for object Y, the change in temperature is lower. So if we have the change in temperature is higher, Okay, this part is going up.